Welcome to this session about nuclear power, and I've subtitled it Why We Don't Trust Anyone with It. This session is actually all about explaining what this process called nuclear enrichment is, explaining what breeder reactors are in the family of nuclear reactors, and just making you aware about why this is such a political hotbed, I guess, and why there's so much world concern about nuclear enrichment programs. So first of all, I'm going to give you some background. There's these thing called fast breeder reactors, and what they were developed to be a more efficient power station, and not only that, they were going to be reducing the amount of needed nuclear fuel, because there's a process embedded within the system which enriches non-fissionable materials, so uranium, which is not practical, not normally one of the isotopes which is not normally used as a fuel, and then it's in this process becomes a useful future fuel. On top of that, it also reduces the total amount of waste product. As I mentioned previously, the nuclear waste is very expensive and very difficult to dispose of. The picture we have here, I guess this touches on some of the issues. This was a nuclear reactor found in North Korea, which eventually had to be suspended, or the construction of had to be suspended due to international pressure. So why was there so much international pressure? I'm going to explain that in a moment. First, let's think about how these breeder reactors actually work. What we have, I've got two types of what's known as fast breeder reactors. Here is one called the liquid metal cooled fast breeder reactor, and it has what's known as a pool design or a loop design. The key thing to recognize here is that within the reactor itself, there's what's known as a breeder blanket. So there's a layer of material which is placed in close proximity to the reactor itself, so therefore it receives any excess neutrons, and these excess neutrons are used to go through the process of enriching. So therefore enriching means converting into a more useful isotope. Now, how this works. Fissionable plutonium is produced from non-fissionable uranium by this reaction. So a fast-moving neutron hits uranium-238. Now, this then causes a change into uranium-239, and that tends only to have a half-life of 23.5 minutes. Uranium-239 becomes neptunium-239, so a different element. This only has a half-life of 2.35 days, which in turn decays through radioactive decay into plutonium-239, which is great because suddenly we have a stable element, because this is likely to survive another 2.44 times 10 to the 4 years. So therefore it's available to be used as a fuel in the future. And this plutonium, when it gets into the reaction, goes through a process of the uranium, plutonium gets hit by a neutron, much like in any other nuclear power station example we've seen. It breaks down through fission into some daughter elements and reduces or produces a further 3 neutrons to allow a chain reaction to take place. That all seems to make sense. Seems a very sensible step to make. Why are there so many issues to do with this? Well, the call of stop all enrichment programs comes from this. Enriched uranium. And this is heavily enriched uranium. So if it's 90% fissionable, uranium-235 is required to produce an atomic bomb. Now, natural uranium only contains about 0.07% of 235 uranium. So a process of enrichment is often required by making it into a compound of uranium hexafluoride and then diffusing it. It's got a complicated process, which is needed to make low enriched uranium, reactor grade. So there's a starting point which we need to go through. But once you've started, if you let this program run and run and run a little bit further, what we find is we need, or you can very soon upgrade this up to highly enriched uranium, which becomes weapon grade. And so therefore it's a question of trust. Do you trust people just to lightly enrich the uranium to make it react suitable for these fast breeder reactors? Or is someone going to keep this process going to make highly enriched uranium which is suitable for weapons? This is why there's the cry for stop all enrichment programs. And this is really, really relevant. Most recently, in October of 2012, there was a standoff with Iran defying Western demands to curb enrichment, and then for Tehran itself making a statement that refined uranium was needed for a medical reactor, because there's some radioactive substances needed for medical facilities. And basically the US and the Allies having a huge suspicion this was being used to develop nuclear bomb capabilities. And fear and warmongering and an unprovoked attack on another nation that could be close by. So this enrichment capacity has caused a huge complication when it comes to diplomatic policy with different countries, and it's all about trust, or as it turns out at the moment, lack of trust for certain nations. So that's why enrichment is important, and this is why understanding enrichment gives you a greater awareness of how the world works today.